Hello everyone, myself Rahul R. Prabhu. In today's presentation, we are going to study about precision rectifier. I am from Tyagaraja College of Engineering. Today's learning outcomes. What we are going to learn today. At the end of the session, the students are able to explain the working of precision rectifier, means they can explain how the rectifier works, the working of precision rectifier we are going to learn today, and the student can sketch the output waveform of rectifier for given input. These are the learning outcomes of today's session. Let's see what are the contents of today's session. Today we are going to learn about precision half wave rectifier and precision full wave rectifier and waveforms for half wave rectifier and also the full wave rectifier. Let's see about precision rectifier. What are precision rectifiers, do you think? What are the need for it? Due to the voltage drop across the diode, we cannot get characteristics of diode as ideal diode. So, the drop across the conducting diode is, as we know, 0.7 volt. So, for getting the precision output, when we connect the diode in feedback path of op amps, which is also known as operational amplifier, we can get ideal diode. This is called super diode. Super diode is also when we placing D diode in feedback loop eliminates error due to VD. Means we get precision output and we can also draw a characteristics graph of diode and it gives the output as similar to ideal diode. So we use precision rectifier. In precision half wave rectifier there are two types. One is inverting and non-inverting. And we are also going to study about precision for full wave rectifier. In precision half wave rectifier, you can see here the diagram of precision non-inverting half wave rectifier. Here we given the input to the positive terminal. The signal is entering here from the positive input. When the half wave, when this figure shows the non-inverting half wave rectifier, here the diode is connected to the feedback path. Signal applied in non-inverting input, and when the positive half cycle runs, the diode conducts. As the diode conducts, we get the transfer characteristics increasing. As the input increases, the output characteristics increases. You can see here in this graph. Like this, in the half cycle, means in the positive half cycle, the diode conducts and we will get the similar output as you can see here in this graph. As the positive half cycle increases, the output also increases, similar to input. In the negative half cycle, the diode is reverse biased. As you all know, in the reverse bias, the diode does not conduct. Means it acts as an open circuit. Here in this point, it acts as an open circuit. The signal does not conduct here. So, in this graph, you can see that in the second half cycle, means in the negative cycle, the diode does not conduct. So, we will get zero output in this graph. Here you can see when the D1 is on in the positive half cycle and the D1 is off in the negative half cycle. Here also mentioned the same thing. When Vin means the input signal is greater than 0, the D1 is on and the operational amplifier acts as unity gain buffer. Is when V out is equal to positive V input. When the V input is lesser than 0, means in the negative half cycle, the D1 acts as open switch and means open circuit happens there, and the D1 will be in the off position, so the V output is off. This is the waveform for non-inverting half wave rectifier. Next we will see about precision half wave rectifier for inverting rectifier. In inverting rectifier, we actually add one diode here in the feedback path. Here we give input in the negative terminal, so we call it as inverting, as you know. So in this inverting precision half wave rectifier, you can see that when the D1 is on, that time the D2 will off due to the inverse bias condition, reverse bias condition. D2 will be off. So in the positive half cycle, you can see here in this waveform, in the positive half cycle, the output comes 0 due to the D2 is reverse biased. In the negative half cycle, it will be reversed. The D1 will be off condition, means it was the reverse bias condition, and the D2 here will be in forward bias. So the D2 will conduct here. So we will get a waveform for the negative half cycle like this. Here you can see the inverting precision half wave rectifier. It will act, means it give output in the negative half wave cycle, but in the non-inverting precision half wave rectifier, it gives output in first half wave rectifier, which also means as positive half cycle. We will get the output signal. Next we will see about precision full wave rectifier. In full wave rectifier, in precision full wave rectifier, we give input to the inverting side. Here we can see that V in, and the diodes are D1 and D2. When we give precision full wave rectifier, means you have to get output in all the time. We have to get the output in first positive half cycle, next we have to get the output in negative half cycle also. We can see first the positive half cycle. In the positive half cycle, when the V in is greater than 0, means D1 is in on position and D2 is in off position. We can see here in this place that when the signal comes here, the D1 will be forward biased and the D2 will be reverse biased. The D2 one will conduct, and D2, due to the reverse bias condition, it does not conduct. So here we are getting 2 times inverting amplifier, so inverting rectifier. So we are having the V output as -1 times of into -1 times of V input. Minus into minus, we get the positive output. So the V output is equal to V input. You can see here, as the positive half cycle conducts, here the output waveform also comes in the positive way. We will next talk about the negative half cycle, how negative half cycle works in full wave rectifier. In full wave rectifier, this is the equivalent circuit of full wave rectifier in negative half cycle. In negative half cycle, you can see here this diode was removed because it was reversed. Here you can, in the previous figure, in this figure you can see here one diode, and this is D1 and this is D2. In the negative half cycle, the D1 acts as open circuit due to it was reverse biased, and here we shown it as that closed circuit due to D2 acts as forward biased and it conducts the signal. Here we given the input in V1. When the V1 is smaller than 0, D1 will be the off and D2 is on. As I told, the D1 here acts as open circuit and D2 acts as closed circuit. Applying KCL at node A. At node A, applying the KCL, we get V in minus 0 by R plus V minus 0 by R and plus V minus 0 by 2R. By adding these all terminologies, we get the final result V is equal to minus 2 by 3 V input. And at final we get this V output is equal to 1 plus R, this feedback resistor, plus 1 plus R divided by 2R, this input resistor, by total multiplied by V. So we get V output is equal to negative of V input. Means here in this waveform, due to the negative of V input, we will get upward waveform in this second cycle. Means in the negative half cycle, we will get the upward cycle for this negative half cycle. Like this, we can draw the waveform by having these two formulas. This is V output is equal to V input in the negative half cycle, and V output is equal to positive V input in the positive half cycle. Like this, we can draw the waveform for precision full wave rectifier. I hope you understand today's presentation. Thank you.